Hello friends, welcome to Data Science Lovers. In our last video, we learned about zeros like, ones like and full like arrays. In this video, we will learn about the diagonal function to create the diagonal arrays. First of all, we will see the definition of diagonal function and its syntax. Then we will use diagonal function on a 2D array as well as on a 1D array. And then we will talk about the k parameter of this diagonal function. And at last, I have a question for you. Let's start. Diagonal function. The diagonal function is used to extract the diagonal elements of an array, or it can be used to construct a new diagonal array. This is the simple syntax of diagonal function. We have to use numpy library. From this numpy library, we have to use diagonal, and the short form is diag. Here in this function, we have two parameters. First one is a, means array, and it is a mandatory parameter we have to use. Second one is k, which is an optional parameter. Here you have to note 3 points. First one is, if a means our array is a 2D array, then the diagonal function extract the diagonal elements of this 2D array. Second point is, if our array that we have passed in diagonal function is a 1D array, then it constructs a 2D array with the elements of A on the diagonal of the new array. These points will become clear as we will do some example. And third point is, by default k is 0. We can use the value of k greater than 0 while considering the diagonals above the main diagonal, and we can consider the value of k less than 0 while considering the diagonals below the main diagonal. First of all, we will import the numpy library, and the syntax, as you know, import numpy as np. The library has been successfully imported in this Jupyter notebook. First, we will consider an example of 2D array. So I will create a 2D array of size 3 by 3. This is my simple 2D array. I will save this in a variable a for our reference. And when I print a, this is our 2D array of size 3 by 3. Now, if we check the dimension of this array, then we can use the endim function on this. It is a 2D array. Now we will use the diagonal function to extract the elements of this array, and it will extract the diagonal elements. How we will do? We will use our numpy library dot diag diagonal function, and inside the bracket, as per our syntax, we will pass our first parameter, which is a. A means array. Our array is stored in this variable a, and when I run this, you can see the output is 159. Here 159, these three elements are present on the diagonal of this 2D array. So that's simple how we can extract the diagonal elements of a 2D array using the diagonal function. Now we will use diagonal function on a 1D array. Suppose I create a simple 1D array. This is my simple 1D array. I will save this in another variable named b for our reference. When I print the b, this is the output. We can check the dimension of array b also. B dot endim. It is a 1D array. Now using this 1D array, we will construct a 2D diagonal array. And this new array will consist of all the elements of this array b. How we will do? We will simply use numpy dot diagonal function again, and here we have to pass our array b. Now you can see all the elements of 1D array 1, 2, 3, 4, 5 are now present at the diagonal side of this new array, and all the other elements are 0. If you see the dimension of this new array, then it is a 2D array. 2 square brackets means 2D array. So that's how we can use the diagonal function on a 1D array and construct a 2D diagonal array with this. Now we will use our second parameter, which is k. I will consider this simple array. For example, this is my 2D array. Okay, now we will use diagonal function np dot diag, and our first parameter array, we are using a array, and this time if I write k equal to 0, if we see the output, then it is showing 159 in the form of a 1D array. This output is same as our above output, where we haven't used the second parameter k equal to 0. It means that by default the value of k is 0 in this diagonal function. This is our third point also. By default k is 0. Now we will use k greater than 0. Let's see what will change. I will use np dot diagonal function again, our array a, and suppose if I write k equal to 1. When I run this, you can see this time it is showing only 2 and 6. Means it is not considering the main diagonal, it is considering the upper diagonal, and the values are 2 and 6. Here also 2 and 6. If I write k equal to 2, then what will be the output according to you? Okay, when I run this, it will show only 3. Means it will consider one more upper diagonal. Okay, so that's how we can change the value of k. Now again, if I use diagonal function on this same array, but this time I give the value of k as negative. Suppose I give -1, then what will be the output? Output will be 4, 8. Means the lower diagonal, the lower side of the main diagonal, and the values are 4 and 8. Similarly, if I use k equal to -2, then it will show output as 7 only. So when k is less than 0, it will consider the lower diagonal. Now we will consider our 1D array with k parameter. I will copy this array again. B is our array. This is B, our 1D array with 5 elements in this. Okay. Now I will use diagonal function again. np.diag, our array B. This time I am considering the B array, and when I use k equal to 0, by default it will show like this. All the elements of our array B will present at the diagonal side of our new array, and all other elements will be 0. And this output is similar to our above output here, where we haven't used k equal to 0. So this is satisfying our third point, that by default the value of k is 0 and the elements will be at main diagonal. Now suppose if I use our array B, and if I use now k greater than 0, suppose if I use k equal to 2, then you can see at main diagonal the values are 0, but the values of this array B are now shifted to the second index from the main diagonal, because we have used k equal to 2. If we used k equal to 1, then it will move only one side upper from the main diagonal. But we have used k equal to 2, or we can use k equal to 3, then it will move accordingly. All values will be present 1 to 5, and the shape of our new array, new 2D array, will change accordingly. If I write k equal to 4, then you can see shape is increasing. When I write k equal to 1, shape is decreasing. We can also use negative value for k, and syntax will be k equal to -1. What will be the output according to you? Okay, when I run this, you can see that the elements of our array B are now present lower side from the main diagonal. Similarly, when I use k equal to -5, then you can see the output will be like this. Means the elements will shifted at -5th index from the main diagonal. So that's how we can use the diagonal function to create a diagonal array and to extract the diagonal elements of an array.